My name is Edward Colone. I'm from the University of Michigan, and today I'm introducing the PSSID Wi-Fi Monitoring System. So the PSSID monitoring system integrates with PerfSONAR. So what is PerfSONAR? PerfSONAR is an open source software consortium that authors network performance metric tools. It has many tools as is, but it also has an extendable API. It includes a plugin development kit, so if you want to integrate tools that aren't currently in its suite of tools, you can use that to ease your integration. Unfortunately, though, PerfSONAR does not natively have any sort of Wi-Fi capability. So we are at the University of Michigan in conjunction with the University of Virginia Tech. We are authoring a piece of middleware called PSSID. It uses a very precise scheduling algorithm based on the Cron syntax. It does the L2 and L3 authentications using WPA supplicant and DHCPD to get onto an SSID. And then it uses PerfSONAR to generate performance metrics through that SSID. It has a GUI for provisioning the probes and for configuring them. And it uses OpenSearch and Grafana for metric analysis. So as we know, signal strength can be misleading. You could have good signal strength, but very poor performance. Active performance testing will reveal the true state of your user experience. There's also a lot of dependent infrastructure, such as like the identity management system. Your entire Wi-Fi stack could be working fine, but if your identity management system isn't functional, then your users are not going to be able to get on the wireless, and they'll probably give you a false complaint saying that Wi-Fi is down. If the gateway to the wider internet is experiencing problems, they might erroneously also report that as a Wi-Fi problem. There's the concept of eduroam with federated logins. And it's possible that the federated login system has problems and the users cannot get on. So the whole purpose of this piece of software is to simulate a user perspective on your Wi-Fi network. In order to make this scale and not have your staff have to learn very complicated configuration directives, we have created a GUI to manage probes at enterprise scale. We use commodity components wherever possible, like PerfSONAR, OpenSearch, and Grafana. And the web GUI probe provisioning is published as a Docker container, and we use Ansible to install that web GUI controller on VMs or hardware and make setup and provisioning of that as easy as possible. The GUI architecture ingests templates that describe the tests that it is able to run through PerfSONAR, like throughput, latency, HTTP for the web. And once you're satisfied that you have created a config that you want enacted on your probes, the web GUI creates on the host VM some output files. It has an Ansible hosts file that contains all the probes, and it contains a comp file that describes the testing schedules and the testing parameters. The engineer will interact with the GUI, and then once the config file and the host inventory are created, they'll run Ansible on that, and it'll push the configuration and any sort of software provisioning needed to the probes. It also relies on using WPA supplicant files, so you can push a WPA supplicant file from the GUI controller to all of your probe architecture. The config file itself has a certain anatomy. Basically, you're creating batches, and then you're applying the batches to either individual host or host groups. The batches consist of let me see here. The batches consist of SSID profiles, the cron job schedules that we talked about, and a testing regimen that consists of jobs, which consists of tests, which are defined by the template files we mentioned earlier. The template files describe the type of tests PerfSONAR can run, and then they're packaged up into the jobs which are applied to the batch. So this is an example of the GUI that you can use to configure the probes. This is the host interface. It allows for creating and deleting of the hosts themselves, and you can add batches to individual hosts using this interface. And then you can also add metadata to hosts. And this is kind of powerful because later on when you're defining your tests, you don't have to statically define everything. You can say that you expect metadata from either a host or a host group, and it will populate that. So this is an example of the group menu where you can create arbitrary groups that either define a class of machines like Raspberry Pis or any other type of hardware that you want, and you can assign metadata to it like interface names. And you can also perhaps create a group that describes a location. Like if you have a certain building or a certain site, you can add all your probes associated with that to that group. And then and a host can be in multiple groups. So once you do that, you can assign batches not just to the individual hosts like we said before, but you can assign them at the group level as well. The schedules, like I said, are a cron-like syntax. This allows for very precise scheduling. If you have a problem where you have a professor in a classroom and it's on Tuesdays and Thursdays, and the class is between 1 and 2, and that's when the performance problem is reported, you can go ahead and you can actually say just that. You're like, I want to run tests on Tuesday and Thursday. I want to run at 1 and 1:10 and 1:20. You can make it very precise, and that lets you really zero in on the times that you want to search for these problems. The SSID profiles describe the SSIDs in your environment, and they correspond to a WPA supplicant comp file that are on the probes. The tests, like we said before, are inherited from a template. They describe the arguments for the tests like throughput, latency, and other attributes. And if you're missing an attribute that you know is supported by PerfSONAR, they have an option to go ahead and add that. The jobs menu, you basically pick out whatever tests you want to add to the job, and you add it. And finally, we get to the batches, which show the test interface, which, like we said before, if you wanted to define different classes of machines with metadata for their test interface, this would be a place to use it. You combine that with the SSID that you want to test, the jobs, multiple schedules if you want, so you can aggregate that, and a priority. So if you have two batches that run at the same time, you can decide which one has a higher priority. Currently, we are hardware agnostic. This is not dependent on the Raspberry Pi 4, but we are using the Raspberry Pi 4. It uses the onboard radios. If we wanted to add support for Wi-Fi 6, for instance, we'd need to add like an external antenna. Our field deployment, we're deploying these in what we call a hardened or secure case. It exposes only the Ethernet port. So we're using power over Ethernet, and we're basically, for security reasons, covering all of the other interfaces. The PoE is also nice because if you have a bunch of these deployed to the field and one of them stops responding, you have the opportunity to go to the router and power cycle it through PoE there as your first level of triage instead of sending someone out to do it. Obviously, if it stops responding after that, then you have to go into deeper measures. The probe configuration and management, We use network namespaces to isolate the interfaces. We use the Ethernet interface to send metrics and receive configuration. The wireless interface is for testing. The algorithm basically reads the config, initializes the batch schedule, and then runs the schedule in a loop. So the algorithm is pretty straightforward. With a combination of tools developed by Virginia Tech and PerfSONAR, we do a layer 2 auth, a layer 3 auth. We run the batch processes through pscheduler, and then we tear the connection down. The batch processing has the ability to say, if one job completes, if it fails, don't run a second job. So we have that. The testing architecture is such that we want to deploy a PerfSONAR node, a wired PerfSONAR node, basically in our data center. So we can test the closest PerfSONAR node to verify that our AP is working, our controller is working, and we get the short haul. And then the long haul we'll test off campus with, we'll hit Google or something like that and prove the gateway is working and reach services that our users expect to be able to reach via the Wi-Fi. This is a screenshot that shows the inner workings of how it does the connection and some of the testing. This is an example of a throughput that PerfSONAR generates. This is done through the Wi-Fi interface. The data analytics pipeline, we use FileBeat on the Pis to forward syslog messages to our Logstash, OpenSearch, Grafana stack, where Logstash filters the results, OpenSearch stores them, and then use Grafana for data analysis on them. This is a quick screenshot, which is showing you that this is a view of our Grafana dashboard showing round trip times between a couple of the Pis that we have in our lab. And this is an incomplete list of everybody who's worked on the project. This year we're doing an alpha deployment of this technology at the University of Michigan. The software is available via the QR code, and we are still in active development. So as things pop up, we are actively looking to improve the features and fix the system as appropriate. So I would like to thank you, and if anybody's interested in using this, go ahead and use the QR code, and the more that play along, the better the software will become. So thank you very much.